In this lesson, we look at the typical causes of estimation error. One of the prime suspects of estimation error, one that we saw clearly in the previous lab, is the confusion between the precision of an estimate and the accuracy of an estimate. Precision and accuracy are two words that we often use interchangeably. In the world of estimation, we need them to have distinct meanings. Let's look at precision first. When we talk about precision, we want to use a definition from the world of measurement. A measurement's precision is a level of discrimination, the size of the measurement increment it has when it's measuring a thing. Lower precision has bigger increment chunks. Higher precision has smaller increment chunks. For example, we're talking about time. A day is a lower precision number than 1,444 minutes. There's the same amount of time. One day is 1,440 minutes, but the minute is a higher precision measure. Minutes have a smaller chunking. If I said this is about a day with its bigger chunks, leads to a different conclusion than if I say this is about 1,440 minutes. Same thing if I was building things. I said we are building some stuff. That's not very precise. It has low precision. If I name a specific feature, that's more precise. It has higher precision. When we use the word precision for a single estimate, we need to ask, what is our unit of measure? How well can we discriminate? Another way we use the word precision is the variability of a group of measures. How much variation do we get when we measure the same thing multiple times? More precise is less variation in the measure. Less precision is higher variation in the measures. In the target example over here, more precise shooter keeps their shots close together. In the less precise example, the shots have higher variation. The one hit smack dab in the middle. Same thing if you look at multiple readings from a GPS system. If the variation in multiple readings to the same destination is small, we would say it is more precise than the one that had higher variation. However, we use the variation sense of precision a lot less in creating estimates than the discrimination sense of the word precision. Precision is one key word. The other word that we use a lot is accuracy. I think accuracy also has two senses in the world of estimation. The primary sense of accuracy in estimation wants to emphasize the sense of trueness. Does the estimate contain the correct value? If you present me with a 2-minute task and I say I can get that done in the next couple of months of calendar time, that's probably true. There's a high probability that this 2-minute task will be done in the next couple of months. The estimate is accurate, but also imprecise. Accuracy as true must contain the actual outcome. In our lab exercise earlier with our narrow ranges, many of us came up with fairly precise numbers that weren't true. Another sense of the word accuracy, and I think this is the one that people often focus on when they say accuracy, is a sense of closeness. This sense is like the variability in precision. Accuracy as closeness says how close does an individual measure get to the actual value, different from precision, which is multiple measures. To be clear, precision variability needs multiple instances or measures. Accuracy closeness often only speaks to just one instance or measure. If I said a task is going to take 2 months, and it took 2 months and just a few hours more, you might say I was fairly accurate. That is, I was close to the actual value, even though it wasn't the true value. This is where we get into problems. There's a relationship between precision and accuracy, and then we're going to use the discrimination sense for precision or x-axis as we talk about accuracy here. To remind ourselves, low discrimination is big chunks like a day versus a minute, or stuff versus a feature. First, let's look at how accuracy as closest increases as we increase discrimination. If I said it would take a day to do and it came out in a day, yeah, you would say I was pretty accurate, but you would not be impressed by that word day I gave because it gave me so much wiggle room to be close. If I say it would take me 1,440 minutes and it took me 1,440 minutes, you'd be much more impressed. I get a lot more credit. Only a little bit of wiggle room on either side of 1444 to be close. Our ability to get credit that we are close increases as the precision discrimination increases. Unfortunately, I think that trueness goes in the opposite direction of closeness. That is, as I increase discrimination, my ability to say that I'm close does increase, but the ability to say that I'm true rapidly decreases because it's harder and harder to hit a smaller and smaller measurement unit. If my task came out to about a day, that is much easier to be true, even if at the little early or a little late as a day, as I have a much more wiggle room than a minute down to the minute. If I said it was down to 14:44 minutes, it's so much harder to be true. It's easier to see that I was off. When we create an estimate trying to deal with this word confusion, we want to sort of lean into this area here, this area over here where we emphasize being true over the possibility of being close. Sure, we want to be close, but it's more important to be true. We want to maximize the trueness more than we want to maximize the closeness. So we got to watch out how well we're discriminating. Confusing early high precision, the potential for getting lots of credit for being close, with being true drives a lot of error. Of course, inaccurate or incomplete information drives a bunch of estimation error. When faced with many unknown things early in the work effort, too many estimators believe that an estimation request forces them to go off to meetings to make educated guesses, make stuff up about the future. They speculate about the project. What teams are going to do what, weeks or months in advance of a product that's not even fully defined yet. They speculate on who will be doing specific things, even though those peoples are not named. They speculate on how stable the project will be, even giving shifting markets, organizational changes, and other considerations. And we do all that speculating, often confusing speculative planning for estimation, as we have inaccurate, incomplete information on the fundamentals of how to create an estimate itself. Our memories are not much help either in avoiding estimation error. Our brains play little tricks on us. For example, we forget a lot of those small tasks that we're actually good at estimating. We tend to remember the big things that need to happen, but we tend to forget all the little work to dot the I's and cross the T's. We also tend to forget how much effort was really needed, probably because we forgot all the daily work that was part of the big work. We also tend to remember our estimates more than the actual result, and this is a big problem. It makes us believe something is so when it simply isn't. After the project is complete or after the release, after a short period of time, when we reflect back on that work, we'll look back and we'll keep thinking about that estimate, that deadline that we kept stressing about day after day. We will repress the actual effort as we never really stressed about that number. Actual outcomes kind of get washed away with time. Anyone who's talked to a leader who claims that they used to do what we're doing in half the time experiences this. A guy named Chris Peters at Microsoft years ago took advantage of this estimation error. One of the things he's quoted as saying is, hey, have the developers doing their own estimates. You never have to fear their estimates are too pessimistic because they'll always deliver a too optimistic estimate. He would then hold them to their own estimates and work the heck out of them. Human beings tend to have a bias to optimistic estimates. Our optimism is often about being hopeful, but more likely we're being tricked by those memory issues, or tricked by inadequate allowance for things like uncertainty and risk, or tricked by the unconsciously trying to answer the how good I am question. Studies have shown that developers in particular, but I think humans in general, tend to be optimistic. One study found a 20 to 30% optimism factor. That is, they were 20 to 30% below a nominal estimate. Many leaders don't buy this optimism. They think their estimators are being pessimistic. One person who took this class had an opportunity to show those leaders the optimism at their company. They were able to gather estimate versus actual data near the end of projects because they worked on the release team. They would get an email from the project saying, hey, release team, be ready for us. We're almost done. These projects and release efforts that are nearing the end of their work. They're trying to alert the release department to be ready. We're about to come with you with a releasable product. And this person said to Construx, I have this golden opportunity. I have the email saying when they think they're going to show up, and I know when they showed up. And so here on this graph, he plotted every time they showed up. On the y-axis versus when they said they would, the x-axis. If they were great estimators, they would show up on the green line. What you notice right away is that there are very few on the green line. Most are delayed, and you can see that the average is over twice as long as the estimated. This is pretty amazing. These are projects near the end. This is not the beginning when we have high uncertainty. This is near the end when it's almost done. And still, We have a strong bias to optimism. This bias just seems to be part of the human nature when we're working on this kind of stuff. What we need to do is believe we are biased and begin to account for that by capturing how optimistic do we tend to be. You can see this group tends to be about 30 days or so optimistic on the average. Ignoring that can drive a lot of estimation error. Another driver of error is that we don't scale very well in the knowledge work. In fact, we have what's known as a diseconomy of scale in knowledge work. Why is that? Well, there's lots of factors, but one of the clearer factors is that when we're working by ourselves is that I don't have to sync my knowledge, my brain, with anyone else. I don't have to take any time to say, okay, let's make sure we're not stepping on each other's work. Let's make sure we're all going the same direction. I don't have to do that. It's just me. Once I bring someone in, I must take some time to sync up with them. I must try to get them aligned. My brain aligned with their brain. As I add people into teams, 3 people, 4 people, 5 people, I start seeing a lot more syncing that I must do. I must stop doing my personal productive work and spend time just syncing with these other people. And after about 5 people, you can start seeing the sync points are getting too big too quickly. One answer is to start forming new teams. If I have more teams, do I have more syncing or less? Well, that's an interesting question because I still must align myself as a team, and then the teams must align somehow. As we grow, we have this a diseconomy of scale that's going to affect our estimates because as we try to say, oh, this task would only take me 3 days, how long would it take this team? Well, that's a different question. We must do some thinking. There are 4 notes that you can take away from this lesson. First is that people often assume accuracy with a presented with high precision. That if I give you a very narrow range, or often no range at all, then you'll think I'm right because I'm giving you a very precise number when it could be very, very incorrect. It is inaccurate. Often based on our memories, and unfortunately, our memories are very poor tools for calibrating estimates. Just trusting your memories is not going to be good enough. We found that people who use simple notes tend to do a lot better estimating than when they're just trying to trust their memories. Compounding that, we as a species seem to have a strong tendency to underestimation bias. We want to think that things take less time, are cheaper, and are faster than they really are. Finally, when things are going slower than desired, when we try to scale up to bigger and bigger teams, this hits our diseconomy of scale. Diseconomy of scale makes it harder to take our individual experience and apply it to a bigger team.